because it's on the exam. Remember, 60% of your exam is AB material. Because it's, for most people, it's too hard to do all of it. Yep. Well, all the other little BC topics, okay? Time to put your phones away. If you don't have, if you have an 83 or 84 and you don't have the programs, Ori and Eric have the programs, they would like to get Remon some program, which is really nice. I do too. Yep, I have that. Could you update that? Yes, you can, but they won't be applicable. Because only 2 problems will be with the calculator. So the ones with Remon sums will probably not be in there. And then we're just going to review this quickly. We're going to have you do this the hard way, because we never did this the hard way. The hard way is to divide into n, an infinite number of rectangles. On the exam, you're not going to have to do that. But you are going to have to be able to recognize the Riemann sum. Okay? Zach, Nick, you need to get your test mail too. Okay, my calculator is missing, otherwise I'd use that. And maybe using one of these, I can actually put this onto my computer. I can try. I think I know how to do it. Okay. Because I did it once. I don't know what happened to that. So we are going to do Riemann sums, and all a Riemann sum is finding the area under the curve. So I don't want you to get upset when it says, find the Riemann sum using something like, in this case, 4 rectangles, and the height computed using the left endpoints. We called that LRAM last year. Okay, Zach? Right. Isn't that only our book does that? You can, which I like about the program, is you get to actually see it. Trapezoids? No triangles. Rectangles? So we're going to use this. We never use triangles. Okay, we are going to go from 0 to 2. And we're going to use 4 rectangles. Because that's what the directions say. What if I do more than 4? Will it get better or worse? Okay. So we're going to find the height of a rectangle using the left endpoint. So it's hitting on the left side of my rectangle. Is that over or under? Yeah, that's under, isn't it? So, and I printed out the values. Now, if this is the case on an exam, AP exam, you use the values in the table. Okay, all phones should be put away. Okay, I want to divide this into 4. So where is my first x? I'm only going to do this. Okay, guys? So if I have 0 to 2, and I divide it into 4 rectangles, how wide is each rectangle? Okay, it's 0.5. So I'm going to take this base, and I'm going to leave all the bases the same, so it's 0.5. And then, if I'm hitting on the left side, it's going to be f of 0. Don't really have a lot of space here. Plus f of 0.5. Plus, I didn't mean to close that parentheses, f of 1 plus f of 1.5. I'm not going to use what? What am I not going to use? F of 2. Now, what do you have to write on the exam? This is not enough. Here, that's not enough. It's close. Enough would be 0.5 times f of 0 is 1. F of 0.5 is 1.25. F of 1 is 2. And f of 1.5 is 3.25. Do you need to add it up? Nope. Don't add it up. Yes. Shh. Guys, you're noisy, huh? Yes. Could you skip this initial step? Yes. This just gives me the plan. This will give you full points. Don't add it up, because I had to take points off for people who added them up wrong. Okay. We decided that was an underestimate, right? Now, what if I use the right endpoints? Hey, Eric, I have my rectangles there. What if I do the right endpoints? It's going to be an overestimate, and this is going to be on the right side. Okay? So it's going to be 0.5 times this height. So we're going to omit the first one. So it's 1.25 plus 2 plus 3.25. Once you get the hang of this, it's actually kind of easy. And that's an overestimate. They will probably ask you that. Or they might use a tangent line approximation and say, is it an overestimate or is it an underestimate? Okay? How do you know which it is? I draw the picture. Okay, Marshall? Hey, guys? I'm not going to talk very long. I draw the picture, unless I get into the general form, which we could do. No, if you just draw the picture, but you should decide if is it concavity or the fact that it's increasing, decreasing. How are you going to know? Draw some pictures. Okay, Eric, do you know how to do the midpoint? Yeah. How do I do the midpoint? Midpoint's going to be trickier. Let's see. So you're going to have to find the midpoint here. And now you're going to have to use the function. So you're going to find the height of the rectangle at the midpoint. Midpoint is the best estimate. What is the function? It's x squared plus 1. So you're actually going to have to substitute those decimals in because I didn't do that. But you know how to do it. That's the point. Now, I don't want you to waste your time doing a lot of arithmetic because that's what this is. So use your calculator. So how to use the program? That'd be a good question. You don't have infinity on your calculator. 2. Because it was from 0 to 2. So, what if I wanted to divide into n rectangles? You guys, this is the hard part. It is, but why? Let's just make this b. Well, let's start here. Okay, guys? Formal Riemann sum. You're going to have it on the exam, but you're not going to evaluate it. You have to recognize it. So I have to go through this. Okay, so I want to find, I'm going to divide this up into rectangles of equal size bases. Obviously not on a scale. I'm going to make them really small eventually. And let's hit on the right side. So my rectangles are going to, in this case, they're going to lie above the graph. Okay, and then I'm going to have a rectangle here. We're going to call that the I1. This is my first x coordinate. How wide are each of the bases? We're going to do an infinite. I want you to see it because you're going to see it and you're going to have to change it back into this. It's hard. So it's b minus 0 divided by how many rectangles? N. Okay? You don't really want to watch this again. You might have to. So the base of each rectangle is going to be b over n. And then you're going to find the height at each of the x values. Okay, you guys over there? I don't know what this is going to be. Can you write that in sigma? You just did sigma for a whole 6 weeks. Can you write that in sigma? It's a series. Sigma, we're going to start with 1 and go to n. And it's going to be f of x sub I delta x. Oh, I did the delta x. Never mind. Okay, guys. Not this sigma. This is a summation from series, not stats. This little one is a sigma. That's a capital sigma. But they're both called sigma. Yes, in Greek alphabet, just like we have. Okay. You know what else I'm going to do with this? I'm going to take the limit and let n go to infinity. Now, that's not what you're going to see on the exam. You're going to see f of x sub I. Well, what was f of x? It was 1 half of x. Was it 1 half? No, it was x squared plus 1, right? Now, the hard part, this is always the hard part, what is x in terms of my diagram? So let's go over here and let's look at this. Stick here. So how many little intervals do you go over to get to x sub 1? Just to get to the first one. What's the width of this? It's b over n. So you go one of those. That's my x coordinate. It's the width of this whole big thing divided by n. What's x sub 2 going to be? How many of those little intervals are we going to get? 2. Let's do another one. And we didn't do this last year, just to save time. This is x2. What? No, it's 2 times b over n. It's not going to be the same value. Oh, how about this one? How many intervals do I go? 1, 2, 3. Because you're going to have to figure it out on the exam. That's the hard part. So I've got to do this now. Then we'll reverse it in about 2 seconds. Okay, what's the I one? Sect? What's the x of I then? How many intervals are you going to get over to this one? You're going to do I. So that's I times the width of the interval. Now that honestly does not look like an x coordinate, but it is. B is just a number. N just says I'm going to let that go to infinity. So when I finally write up my complete Riemann sum, it's going to look really strange. It's the limit as n goes to infinity, and it's b over n, that's my delta x, summation I equals 1 to n, and this is going to be, my x is going to be this thing I'm going to put in for x. So it's I times b over n squared plus 1. What if they told you n was 50? What would that look like? Now, what does that mean? If I tell you there's 50 divisions there, how many rectangles do we have? Because it was x squared. I'm sorry, what? You get 50. 50 rectangles. So 50 just tells me I didn't go to infinity. I've seen this problem on the exam. Eric, it looks like b over 50, and it would look like I equals 1 to 50. Eric, IB over n squared plus 1. Oh, n is 50, though. Now, what you are going to have to do is you are going to have to figure out what that integral is, because you guys remember, this is the integral from a to b of f of x dx, because Riemann said, I don't want to write that summation. Is the 50 really important? Could it be 80 or 100? Is it part of the function, or is it just how many rectangles I have? Just how many rectangles. So what's my function? This is the x coordinate. So it's the integral from x squared plus 1 from a to b. Where did we start? At 0. So it goes 0 to b. And then you need a dx, because that's your delta x. And you know how to do that because you know how to integrate, which we'll get to. But you would know how to do that. So when you see this on the exam, they might not even ask you to integrate. They might say, which integral represents this? Now, you know if I'm talking about it, it's important. Right? Probably on the test. Anything I talk about is fair game. I'm hitting on it because it's important. What if you didn't start? Okay, Eric, what if you didn't start at 0? What if you started at A? Yeah, but what does the x-coordinate look like? Okay, how wide are each of the intervals then? What's delta x? Or what's delta x? No, it's this entire width divided by how many rectangles? N. Then what's the first x coordinate? Here's x1. It's my f of x. So how do you find x1? Well, first off, you have to go over a units, right? A spaces, plus one of these little delta x's. You could do one delta x, then I don't have to write so much. What's the second x coordinate? I think they're going to start at 0, because this is hard if you don't start at 0. It's a plus how many? 2 delta x's, because I have to get over here. It's all geometry. What's x sub 3? x2, here's x3. A plus 3 delta x. It's just a shift. What does the x sub I coordinate look like? A plus, and then it's going to be n delta x's, right? Or no, not n, I. I is just the counter like we did last semester. I starts with 1, 2, 3, and I will stand for the I one. If I want the 50th one or the 100th or the millionth one, and the last one will be n, and it'll let n go to infinity. So if you don't start at 0, you're going to have that little piece right there. Now, I don't think the assignment's too terrible. If you have my program, it's really easy. And I borrowed their calculator. I'm going to try and put it on my calculator. That's nice to demonstrate. But it says, get my Riemann sum program to help you do the homework problems. And I have to go get some more assignment sheets. But the assignment is not too long. Tomorrow we're going to go on to 5-2. We have to fly through these chapters, except that we have to do some more BC topics within this. That's what the little stars are, I believe. I believe that's what the stars are. So it's only 5 problems. So I'm going to pause this and see if I can borrow a calculator. See if I remember how to do this.